Hello everyone, I am Prabhu Beven Marad, Assistant Professor, Department of CSC, BLD CET, Vijaypur. In this video, I am going to discuss about geometric distribution, negative binomial distribution. So let us first understand geometric distribution. The geometric distribution represents number of failures before you get a success. That is, before you get a first success in a series of Bernoulli trials. So the following are the assumptions for geometric distribution. So there are two possible outcomes for each trial. So they are success or failure. The trials are independent, that is, the result of one trial will not affect another trial. The probability of success is the same for each trial. The geometric distribution is frequently used in data networks. The number of Bernoulli trials x to achieve the first success is given by, that is, P of failure after the first success, that is P of x equal to q raised to x minus 1 and p raised to 1. So, q raised to x minus 1 is nothing but the failures, that is x minus 1 failures, p raised to 1 is the first success, where x equal to 1, 2, 3 so on up to n, and it is 0 otherwise. The mean of geometrical distribution is given as 1 divided by, that is p, and the variance is given by, that is q divided by p square. Negative binomial distribution. A negative binomial distribution is an experiment, that is a statistical experiment that has the following properties. The experiment consists of x repeated trials. Each trial can result in two possible outcomes. So, we call one of these outcome as a success and other as a failure. The probability of success denoted by P and is same on every trial. So, the trials are independent, that is, outcome of one trial does not affect the outcome of other trials. The experiment continues until k success are observed, where y is specified in advance. The number of Bernoulli trials x until k success, if y is a negative binomial distribution with a parameter p and k, then it is given as p of y equal to y minus 1 combination k minus 1 q raised to y minus k and p raised to k. So, p raised to k is nothing but the success, k successes, and q raised to y minus k is nothing but failure. So, y is given as, that is y equal to k, k plus 1, k plus 2 so on. So, the mean is calculated by, that is k divided by p, and variance is k into q divided by p square. So, let us solve the problem. 40% of assembled inkjet printers are rejected at the inspection station. Find the probability that the first accepted inkjet printer is a third one inspected. So, considering each inspection as the Bernoulli trial with the failure is 0.4, the probability of fail is 0.4 and success is p, that is 0.6. So, we have to find the third inspected printer is third accepted. Okay. So, p of 3 is, so this follows the geometrical distribution. Therefore, so the first success is, we are looking for the first success, the third one inspected. So, therefore, so p of 3 equal to 0.4 raised to x minus 1. So, the value of x is 3, minus 1 is nothing but 2, and the value of P is 0.6 raised to 1. So, this is given as 0.096. Thus, in only about 10% of the cases, the first acceptable printer is the third one from any arbitrary starting point. Then what is the probability that the third printer inspected is a second acceptable printer? So, here we are going to we are looking for the printer k printers which are acceptable. So, therefore, the value of k is what here 2. So, this follows the negative binomial distribution. So, therefore, p of x equal to y minus 1 combination k minus 1. So, q raised to y minus k and p raised to k here. So, therefore, p of 3 equal to third inspected printer. So, therefore, p of 3 equal to 3 minus 1 2 minus 1. So, 0.4 raised to 3 minus 2 and 0.6 raised to 2 here. The 2 is value of k and 3 minus 2 is nothing but what here that is y minus k. So, after evaluating the equation, so we get a value final value as a 0.288. So, this is what here the probability of the third printer inspected is a second acceptable printer. Thank you.